Welcome to Mathmaxtra. This is Saritha. Today our topic is types of algebraic expressions. So we have different types of algebraic expressions. So we'll see one by one in detail. The first one is monomial. Monomial. You see the name itself telling us mono means a single. So what is monomial? It is nothing but it is an algebraic expression which contains exactly one term. So whatever may be the term, that must be algebraic expression first. Means it should contain at least one algebraic term, right? See, you take one example, 7x. Okay. So is it an algebraic expression? Yes, 7x is an algebraic expression because it contains at least one algebraic term. Okay, so it is an algebraic expression and it should contain exactly one term. So this 7x is nothing but one term only, right? So that is why we call this as a monomial. Okay, see 6x square y. Is it a monomial? Yes, it is a monomial. It is on exactly one term and it is also an algebraic expression. That is why we call this as a monomial. Okay. The second one is binomial. What is binomial? See, binomial is nothing but it is also an algebraic expression which contains exactly two terms. Not at least, not at most, which should contain exactly two terms. Okay. See, you take one example, 7 plus 3x. Is it an algebraic expression first? Yes, it is an algebraic expression. Okay. So, does it contain exactly two terms? Okay. Yes, it contains exactly two terms. But what are those two terms? The two terms must be unlike terms, isn't it? If you take one example, that is 3x plus 5x. Is it a binomial? No, right? Because see, these 3x and 5x are like terms, isn't it? Both have this term and this term both have same literal coefficient. That is why we can add them easily. Yes, if you add them, what it becomes? It is a monomial. So it doesn't represent a binomial. That is why in the definition we have to mention that an algebraic expression, it must contain exactly two unlike terms. See, you look at this example. This is 3x, this is 7. This is one different term and this is one different term. These two are unlike terms. That is why we call this expression as binomial. Okay. And the third one is trinomial. What is trinomial? Trinomial is nothing but it is an algebraic expression and it must contain three unlike terms. Okay. You take one example, 7 plus 2x plus 3y. Is it a trinomial? Yes, it contains exactly three unlike terms. This has a literal coefficient x, this has a literal coefficient y, and it doesn't have a literal coefficient. So these three are unlike terms. That is why, and these three are exactly three terms. 1, 2, 3, exactly three terms. That is why we call this expression as a trinomial. Okay. And the fourth one is multinomial. What is multinomial? And it is an algebraic expression which contains two or more than two unlike terms. Then we call that as an multinomial. Means this multinomial may contain two terms, three terms, four terms and so on. Two or more than two terms which are unlike terms. Then we call that as a multinomial. Now tell me whether all the binomials are multinomials. Yes, all the binomials are multinomial. See, all the binomials contains exactly two unlike terms, isn't it? Then, so according to the definition of multinomial, if an algebraic expression contains two or more than two unlike terms, then we call it as a multinomial. That is why all the binomials are multinomials. Now tell me whether the converse is true or not. Means whether all the multinomials are binomials. No need, right? Because see, multinomial may contain two terms, three terms, four terms, and so on. It may contain any number of terms. If it contains two terms, then it will become binomial. If it contains three terms, then it will become trinomial, not binomial. That is why converse is not true. So what we can say? We can say a note that all the binomials are multinomial, but converse need not be true. Means all the multinomials need not be binomial. So these type of statements you have to remember, because in the questions the statements are given like this only. So there you have to identify whether the converse is true or not. So if you remember these statements, you can answer easily. Okay. Now all the, not only binomial, all the trinomials are also multinomial, isn't it? Same thing. So all the trinomials are multinomials, but all the multinomials need not be trinomials. Okay. Now what is a degree of a monomial? See, we have seen what is a monomial. What is a monomial? An algebraic expression which contains exactly one term. See, I am taking one example. 7x square y is my example. Okay, now what we called as a degree of this monomial. See, the degree is defined like this. Okay, the sum of all the exponents of variables. See, this is a variable, right? This x is a variable. So what is the exponent of this? 2, isn't it? And this is one more variable. What is the exponent of this? 1. So sum of these exponents, which are nothing but 2 plus 1, which is equal to 3. So 3 is our degree. Means sum of the exponents of all the variables in the given monomial. Then we call that as a degree of a monomial. Now tell me 5xyz. So what is the degree of this? See, this has one exponent, this has one, this has one. So what is the sum of all the exponents? 1 plus 1 plus 1. So the degree is equal to 3. Degree of this monomial is equal to simply sum of all the exponents of the variable in the given monomial. Okay, so degree is 3. Like this we can define degree of a monomial. Okay, tell me whether if you take two like terms, whether they have same degree or not. So I am taking 3x square y. Okay, 5x square y. So these two are like terms. So whether they have same degree or not. See, x square y, it has degree 3. Okay. So what about this? This also has degree 2 plus 1, that is 3. So both the like terms have same degree, isn't it? So whether the converse is true or not, means if you give same degree for both the monomial, whether they are like terms always? No, right? See, so this is example for if you take two like terms, the degrees are always equal. So if you take degrees are same, means I have taken 3 degree terms. So one is 3x square y and other is 3x y square. Now tell me, see, this has a degree 3, this also has degree 3. Now tell me whether these two are like terms. No, right? This is x square y. This is xy square. These are not like terms, but they have degree same. So our note point is always two or more like terms always have same degree. Okay. But if you consider same degree terms, they need not be like terms. Okay. So this is our note point from this. So standard form of an algebraic expression. So sometimes we have to identify whether the given expression is in the standard form or not. So that time, so we need to remember what is a standard form. See, I am taking one example. 5 plus 3x square plus 7x. So now tell me whether this given expression is in standard form. Okay, now we will define what is the standard form. Standard form is nothing but we should arrange the terms of the expression according to the descending order of their degrees. So first you have to find out the degree of each term. What is the degree of this term? As it doesn't have any literal coefficient, means it doesn't have any variables, the degree is always 0. Okay. So what is the degree of this 3x square? It is 2. What is the degree of 7x? It is 1. Now you arrange these degrees of these terms in the descending order. So what is the highest number in this? 2 is the highest number. So you write 3x square term first. Then 1 is the highest. Okay. Write 7x term. Next 0. So the related term is 5. So now this expression is in standard form. So what is the standard form? We have to arrange the terms of the expression according to descending order of their degrees. So then we can say that is in the standard form. Okay. Degree of any constant term, not only 5, degree of any constant term is always 0. Okay. Just before we have discussed the degree of a monomial. Now we will in general discuss the degree of algebraic expression. Algebraic expression is maybe monomial or binomial or trinomial and so on. So it can be anything. So how to calculate a degree for such type of expression? Okay. Now we will see. Is a degree of an algebraic expression. See, I am considering one algebraic expression which is 5 plus 2x square plus 3xy. Okay, so this is an algebraic expression. Okay, now what is the degree of this expression? It is defined as the highest degree of all the terms of the expression. So you first write the degree of individual terms. So what is the degree of any constant? It is 0, right? So what is the degree of this 2x square? Sum of all the exponents in this term. In this sum of exponents of all the variables. It is simply 2. So what is the degree of this? Sum of all the exponents, right? 1 plus 1, 2. Okay. So among all these, the highest degree, among all these, what is the highest degree? It is 2, right? So among all these, the highest degree we call it as a degree of this total expression. So now degree of this expression is nothing but which is equal to 2. Now tell me 3 plus 2xy plus 4x square yz. Now tell me what is the degree of this algebraic expressions. Now see, so this is degree 0. Okay, now this is degree 2 and this is degree 2 plus 1 plus 1, 4. So among all these, what is the highest degree? 4 is the highest degree. That is why we call 4 is the degree of this total expression. Okay, so degree is 4 in this case. Okay, so this is how we can define degree of an algebraic expression. An algebraic expression, then how to calculate the value of that expression at the given point. See, I am considering 3 plus 4x square plus 2x. This is our algebraic expression. Okay. So now he will ask the value of this algebraic expression at x is equal to 1. Then how to calculate the value of that expression at that point? So you simply substitute x is equal to 1 in place of this x. Okay. You simply substitute 3 plus 4 into 1 square plus 2 into 1. Okay. 3 plus 4 plus 2, 9. So 9 is the value of this expression. So this is how we can find out the value of the given expression. Okay. Now we will define what is a zero of an algebraic expression. So what is a zero of an algebraic expression? So if you substitute a value in the given expression, if the total expression value becomes 0, then we call that given value is a zero of an algebraic expression. You see 3 plus 2x square plus 4x. So this is our algebraic expression. So we have to check whether x is equal to 1 is a zero of this expression or not. So what we have said, if you substitute this value in the expression value should become 0. Then we call this x is equal to 1 is a zero of this algebraic expression. Now we will check whether it is a zero of this expression or not. See, simply 4 into 1, 3 plus 2 plus 4, it is 9, right? Yes, it is 9. So, which is not equal to 0. That is why we can say this x is equal to 1 is not a zero of an algebraic expression. If this expression value becomes 0, then we can say this x is equal to 1 is a zero of an algebraic expression. Okay, did you understand what is a zero of an algebraic expression? So you can find out if sometimes we need to check whether the given value is a zero of an algebraic expression or not. That time you can do like this. Okay, thank you.